So, good morning, everyone. I'm Riccardo Zamana. I speak from Italy, from Venice especially. Today we will talk about an important service, an important platform as a service that is rising up the world of telemetry based and time series databases. And we are talking about Azure Data Explorer. And today we will talk about ADX with a particular focus on its own usage about IoT use cases. Why? In order to introduce myself, more or less, I work in the IT from more than 20 years, but I was one of the first ADX fellow. So from when it was made as a public service on February 2019. In order to go on quickly, I don't know exactly if you are an expert or an intermediate user about ADX, so I would like to introduce the service itself. So in a sentence, what is ADX? ADX is a platform, a cloud platform, fully managed. It is not served as an on-premise database. It is only distributed by Azure. You can use it as a sort of a big data database, but in order to make analytics, so filter, aggregate, join, and explore data. And it was an internal service in the Microsoft Word. It was used about all the internal logging. And today we can find the Kusto query language. Kusto is the query language of ADX, of Application Insights, Log Analytics, Azure Monitor, Azure Sentinel. So it is a commonly used query language and is derived from ADX. And so if you want to use ADX, you have to deal with the Kusto language. Fast and fully managed. Why? It is very fast because you can introduce the data, you can ingest the data in more than one way. ADX from the Lambda point of view has got the hot path and the warm cold path. So you can stream the data into or batch the data into. And it was designed from data exploration, but it can be used in many ways, even in data warehouse, fact and dimension manner. And with ADX, you have the possibility to not only having a data ingestion platform and a sort of time series based database, but you can also have a complete UI and a complete orchestration system and a sort of link with big data streaming platforms such as Spark or in general R and Python programming. Which are the use cases? My favorite, because it is a part of my daily work. Azure Data Explorer can be used in IoT applications. So imagine that you have assets. Today we will talk about asset monitoring, and using ADX you can ingest in a batch way or in a streaming way all the data that comes from the plants or come from cars or come from digital assets located into an environment, so a smart building, a smart city, and so on. And you can acquire all the signals and analyze all the signals and maintain, that is important way, maintain the data in the long term using a sort of progressively transformation of the data in order to bring down the frequency, from month to month, and elaborate the data as you do usually with the data lake, so the bronze, silver, gold elaboration of the data. In this way, you can use it with IoT application or with the big data logging applications. So if you have a huge amount of logs, and when I mean logs, I don't mind JSON or CSV. I use semi-structured or not structured data. And with, for example, the parse function in ADX, you can bring the semi-structured data and take it into completely managed database with the fact dimensions, okay, tables. And the third one, I have my colleagues that use ADX in order to distribute software as a service. So, for example, one of my best friends use it in another company that is an automotive company. And within that company, they use ADX as a sort of baseline of data because they deliver a rent car software as a service applications, okay, in order to do things like anti-theft or monitor position within a parking and so on. And they use ADX as the completely backend, okay? And in front of the ADX, they use only a web application that speaks with ADX using APIs, okay? So it is a very flexible service. You can use it in many ways, not only to explore data, but to maintain data and to link various sources and data contexts. But we talk about data context now. Data context, you can have cloud contexts or on-premises contexts. In my life, for example, I've used ADX in order to ingest data from Amazon, okay, and from a partner, and then bring the data into our own infrastructure. Contexts like IoT providers on Azure, for example, but not only on Azure, and other data lakes, okay? ADX is capable of handling many data types, okay, more formats, sources, and it deals with structured data, semi-structured data, unstructured data like free text, okay. And so it is designed for speed and simplicity for the end user, but it is very complicated to use ADX because from the morphological point of view, it is a compound of many services, okay, that are simplified because all around that there is only one unique name. But imagine that you have two pipelines, the streaming pipeline and the batch pipeline, for example, that are independent components within ADX, okay? The data management is another component only dedicated to brings the data from the two main flows into the right extent, so the right partition, the right shard, as you like. But after that, there is another component that is the engine, that is not only the query engine, is the cache engine, for example, and the manipulation data engine. So in order to bring the data from one piece of data platform, the data management component, to another data managed component. So from one shard to another shard, from one extent to another extent. On top of that, there is a lot of APIs in order to deal with SDKs, Python SDK, R SDK, or REST API SDK. And on top of that, there are other components. One of them is the UI. All these components are simplified into one, okay? So it is a strange from a particular point of view, because, you know, when you go to a cloud supermarket, you want to buy the single building blocks. ADX is different. It is a sort of platform solution, completely powerful from any point of view. So the input, the output, the UI, the data management, the security. So with one service, you can do everything you want. From the query point of view, yeah, you have to deal with another language. So Kusto is different from SQL. But for example, if you want to start to learn how to create your query, and you start with SQL basic knowledge, you can do your own SQL queries. Remember that prior to write down the select word, dash, new line, select, and so on, and ADX query will be translated, so the result will be not the query result, but the Kusto equivalent query. And in this way, you can learn step by step this language. It is important to say that it is not only a query language, so you can render out your query in the same instance. Okay, so pipe render and choose one of the 11 charts types. It is very comprehensive, so you can do your filters, but you can summarize. But overall, you can extend the query result with the new fields, new columns that are derived from some operation within the initial data. So how to provision it? It is simple. I don't want to bore you with so simple procedure. Keep in mind that the provisioning is not so quick, more or less from 15 to 20 minutes. The provision of an instance, okay? Within the instance, you have other entities such as databases, and the provision of databases is very, very quick, so less than 1 minute. But I would like to introduce you with what is ADX for me today. When you deal with telemetry, you have to search data, for example, because you are in an environment that is not structured as you want initially. And so in the past, I use ELK, and ADX is a good replacement of that. But when you deal with IoT, for example, you have to deal with time series databases involved in a Lambda replacement, okay? And so in the past, when I used open source softwares such as Kafka, RabbitMQ, and so on, or MinIO as a sort of S3 compatible storage. Now I have only ADX as a Swiss knife, and I make my own work only with that. It is a tool, basically important tool in order to transform data, to materialize data to other two important services. One of them is Data Lake, Azure Data Lake Store, and the other one is SQL. So imagine that when you deal with IoT, you've got the initial data that is not cleaned data, and you want to put the data into a golden database, okay? All this work can be made only by using ADX, without programming C#, okay? Only program some line of Kusto or some configuration line, nothing else. So very, very useful. And if you want to have, remember, if you want to have a complete monitoring database, in order not such event hub, okay, as a log streaming service, because the window of an event hub is not so long, so 7 days. It is useful, yes, but in another cases. But if you want to monitor and have a completely understanding of what is happening about users, events, people, assets, only in one service, from my point of view, ADX is the unique service that exists, okay, in order to summarize information, correlate information between people and assets and processes, for example, and using another simple service that, for example, is Logic Apps, okay, that is fully integrated with the ADX. You can periodically send queries, okay, to ADX. You can send notification. But the important meaning of ADX is to centralize all the data acquisition and ingestion phase. Well, only the quick start. So when you deal with IoT, you have to deal with multi-temperature data. So hot, seconds, warm, minutes, cold, hours or days. In the past, there were multiple data pipelines in order to deal with these three kind of situation. But in IoT, you have all of them, and with ADX, you can have only one thing to rule them all. Okay, as we said. The role of ADX, so, is to bring the data from the raw data format to, for example, data warehouse, or out of the ADX world in order to consume data using a normal database or store data into a normal data lake and so on. But the three roles and the three key users involved in the ADX usage. So ADX is not a data engineer tool. It is not a developer tool, okay? It is a platform tool, at least for three kind of users. The IoT developer, data check, rule evaluations, okay, thresholds, anomalies, clustering of data, okay? And in order to retrieve insights automatically, so in order to distill information from raw data into silver or gold tables. The second one is the data engineer. For example, in industrial IoT, data engineer is the process control engineer that have to compare the data from a sensor that is coming out now or yesterday, okay, had come out from a machine, with the same thing with the equal, okay, production order, but made 6 months ago. And so they have to compare data and compare telemetry situations. So the same production order with the same raw material, with the same assets, how is going? And the third one is the data scientist. So data scientist, prior to make algorithms, machine learning algorithms, have to deal with, for example, notebooks in order to experiment data step by step. Or can explore data in order to clean the data, in order to select the correct signals to be exported to a data lake. It deals with backfill of the data and resampling of the data in order to have all the timestamps in the same way, aligned with the values in that time for every sensor. And this is made with the ADX. Okay? How is organized? As I said, an instance, 20 minutes. Okay, cooked 20 minutes. A database, more or less 1 minute. So when you say a database, every database has got two URLs. One for the ingestion, the streaming ingestion, and one for the query. Every database has got a data management blob storage based component and every database has got a cache storage component dedicated. When you deal with the database, probably you want to collect data into that database from some input. And so you have to deal with sources. Sources are simply configured within the Azure portal or with some DSL, okay, so PowerShell and so on. So IoT Hub, Event Hub, or storage. In my world, so industrial IoT especially, we deal 90% with the batch way, because, for example, when you have to monitor an asset that is a machine, you want to have in real time or the status change of the machine, so the start, the stop signal. And probably the best way to ingest the data is to ingest with the streaming pipeline. But all the process data, so sensors, in the real life are ingested using the batch data. But it is not finished, the fabulous story, because there are other two important settings. One of them is regarding external sources. Why? Because you can use not only the data that comes from the field, but you can link the data that already came from another database or from another data lake. And then finally, the last important thing to say is the external destination. So when the data is ingested, is the data story finished? No, absolutely not, because there are many situations in which you want to not to connect ADX to Synapse, okay, or use ADX as a sort of source, as a sort of input for the Azure Data Factory, for example. But you want to export data natively from ADX to a data lake or to a SQL database. And you can do that using the exporting function of ADX. And so you have to deal with the external destinations. Let's go to the first phase, because the time is running out. First phase, ingestion. Remember, you can use many ways, but if you have to experiment with the data, you can use the one-click ingestion or a simple line tool. It is an executable that you can download from internet that is named as Light Ingest. Light Ingest is a tool-based on a simple dialect in order to launch this executable with some parameter in order to bring data from your computer directly to ADX or from a remote URL passing to your computer automatically and then go to ADX. In order to go on, I prefer to go over this slide, but remember that you can use ADX linking also with linking that also with the Azure Data Factory, especially with the integration runtime located in an on-premise environment. So imagine that you have an industry or a classical on-premise data center in which you have internal databases and so on, and you want to bring this data and put it on the cloud. You can use, for example, ADF Data Factory with an integration runtime installed locally to move the data directly into ADX. If you want to develop something, there are many SDKs, okay? I only tested two of them, the Python and the .NET, are mature. So, gestion types. Streaming. Imagine that if you want to manage the information exactly in the moment in which is sent into the cloud, don't use ADX. Because even if the word is streaming ingestion, it is not near real time. So more or less 10, 15 seconds before seeing the data ingested into the database. Okay. The batch ingestion is very, very powerful, very powerful. And so, for example, in industry, when we talk about the warm path, we are talking about 2, 3, or 5 minutes of delay between the data generation and the data acquisition. Okay. And so you can configure the batch ingestion parameters. One of them is the default timing. Okay. But when you want to test the data, you can use inline ingestion. If you go to the documentation, you will see the possibility to store the data within a query in a let variable, LET. And so you can bring the data, copy and paste directly into the query, and use it as a sort of sample in order to test your query. Okay, when your query is okay, you can do other things. We will talk about that in a few minutes. And you can use Azure Blob Storage as the destination of batch ingestion. And batch ingestion is the recommended technique. About formats. Oh, the formats are too much formats for me. And two things are important to say. The first one, choose correctly the format, because it depends on format, the performance, the capability of ingest data, because sometimes it's not possible. For example, when you deal with the dynamic morphology of the fields, you can establish prior to ingest the data, the morphology of the table, because the table is variable. It is not good. So if you want, you can normalize at the starting point, so in the edge, at the edge, when you are composing the CSV, for example, or the Parquet file, or at the end of the story, but you have to just with JSON. So the first one is choose the right format. In my case, but in my own case, so IoT, I prefer to use Parquet because it is a sort of compression ratio. So in order to avoid too much throughput, I prefer to compress the file using the Parquet format, and after that, the zip format. But when you use a Parquet format, the zip is not very strong another compression. Okay, so because Parquet is compressed at all. Imagine that you have a sort of relationship from 1 to 7. Okay, this is the ratio. If you declare if you want to use the zip format, simply declare the name in this way. So dot the file format dot zip, nothing else. So when we talk about mapping, we are talking about how ADX consider the inputs, the file inputs, in order to create the correct or use the correct table. And the CSV format it is a strong format because every line has got the same columns. So the schema mapping is not mandatory. Schema mapping is the definition of the table and the possibility to map the fields that come from the file to the right ordinal of the table. And this settings is mandatory when you deal with the dynamics, so JSON mapping. So when your PLC, okay, for example, sends many data, but not in that moment every kind of every process control variable, because some variable is event based, so it is not sampled. Okay, it is an unchanged variable that is generated from the PLC. So in this way, you have to deal with the JSON mapping. So please use a zip file, because JSON is not very good from the compression ratio, obviously. And some example, okay. For example, the injection mapping with the CSV. So the column that must be found in the ingested file, and the properties that you can use in order to set which is the ordinal, or for example, which is the constant value that can be placed into the table. And this is the first way in order to enrich the data with some field. Okay, it is slightly different from the JSON perspective, and because you have to deal with the JSON path, for example. And so we are not dealing with the ordinal in this example, but with the path. So the $dot and you have to navigate the right attribute to be placed in the right column. Now, talk about how to design the correct IoT schema. I apologize, but I lose my last visio graph, but I would like to tell you about it. Imagine that even if ADX is not signups, okay, they are different. There are no competition between them. They are located in the market in two distinct places, and you can use them in conjunction. Okay. But if you want, you can use ADX in order to have a sort of fact dimension schema, such a data warehouse, in order to explore data. Okay, and so which is the correct IoT schema? All right. First of all, fact tables. Please don't use too many columns in the fact tables. Imagine that ADX, okay, has got a sort of limit, more or less 3,000 or 4,000. I don't remember exactly the number, but some thousand of columns. But normally you use 3, 4, 5, 6 columns in the fact table. So the entity data is in the fact table contains an identity, a date type, and the value, and the sensor name, for example. 4. No other columns, because you have to deal with the join query with the reference data. Okay, what we call the reference data in stream analytics is the same concept. So all the dimensions can be imported or linked by external table using the external tables. So imagine that you have a SQL table imported as a sort of external source and used in a join with the fact table that is internal in IDX. In that way, you can, at the runtime, build up new silver tables. Let me show you a screenshot, okay? Only a screenshot. For example, this is the mapping table, okay? So the a sort of let's describe the mapping table: tag time, tag name, tag ID, description, and other things. Okay, the mapping table. Mapping. What do you mean with mapping? Mapping between fact and dimension. So raw data, simple, timestamp, tag name, value type, and status, for example. And this is the time series silver. And this is a sort of a sort of target table. Okay, so it is the merge of the raw data and the mapping table. What we how can I say, these lines represent an important thing in ADX. It is a sort of procedure. Sorry. It is a sort of procedure that make a sort of join and projection of the data between the mapping table and the fact table. In order to do what? In order to project a new table. That is the time series silver table. In that table, there is the join between the fact and dimension. And in this way, imagine that this function is an automatical function. And every time some data comes into the raw data, the time series silver data is updated. So we are talking about the update policy that is one of the key concepts in ADX. With this function, you can enrich the data, enrich the raw data in order to build up a time series silver table. There is no time. I apologize for the demo. In order to summarize what we have talked about until here, this is my best experience. It is slightly different from the standard methodology, but it was good to me. When you first of all, when you link as an external source the storage account in which you dump the telemetry from the field, and ADX automatically Azure creates and link together other two services. One of them is Event Grid as a sort of a trigger service. Every time I put a new file created trigger rise up in Event Grid. Event Grid, it is a sort of subscription, okay? And send the data details, so the event trigger as a sort of JSON to the event hub. And so in the event hub, you don't have the data, but you have the EG JSON. And this is a standard format for ADX, and ADX brings this notification, and after that manage the raw file. There is another way. If you notice, I am not linked directly, even if it is possible, IoT Hub to ADX, because in the real world, there are many times in which all the data that comes from the field is not a DTDL based JSON. So you have to manipulate it because sometimes you not deal with the edge, you deal only with the cloud, and so don't expect that the data is cleaned. Okay, so this is an approach in order to fix all the data that comes from the field and clean the data, or for example put away all the payloads that are not compliant with your owned schema. And so we typically use a function app in order to do this kind of things as a sort of router with some logic inside, and putting the data into another event tab. So the cleaned data is put into another event tab, and the event tab is correctly linked with the ADX. But we were talking about update policy. Let me introduce you this basically important thing. The update policy permits to elaborate the data that comes into the row table into a refined table. Okay, imagine that you can have, for example, a row table with two fields, a timestamp and a text. And with an update policy, you can refine the data using the timestamp and the columns that are the result of a parsing function. So the update policy permits to elaborate the data using what we looked some minutes ago. So a function, okay. So it is a sort of query with a projection inside that elaborates the data and brings the result into another target table. Remember that this kind of elaboration can be made with the cascading chain of calls. So from the same raw data, you can build up more than one point of view. So many target tables from one side, from the asset side, from the producer side, from the raw material side, as you want, or there are good data, even if it is duplicated, but is, for example, aggregated, filtered with different ways. But remember that you can do that applying the update policy, many update policies in a series or in parallel. How to use it is as simple as we said. Create function, my function. Inside the function, there is a query with the join, for example, a summarize, for example, and a projection, for sure. And if you don't have the target table, you can declare it using, it is important to note this, using the result in terms of morphology of the function. But with the pipe limit zero, when you execute the set or append, it brings only the morphology, but not the data, because there is the limit zero. Very tricky, but it is a very good approach, because many times you do not have a clear perception of what is the data, or you want to change experimenting, okay, and this approach is the most fast. After that, you have to alter the policy update of the target table. So the update policy is appended to the target, not to the source. And so with this line, okay, alter table policy update, you can enable or disable and declare which is the query, and obviously declaring if is transactional. And sorry for the time, but there's a very huge amount of information inside the ADX. When you ingest data, you can in the row table, so in the first table, you can put some metadata, okay, some tag This tag is fundamental when you have to deal with extents. So when you want to deal with the partitions, or when you want to deal with the logical separation of data in general. If you want to propagate the ingestion properties, so this kind of metadata, you have to set to true, okay? And so the update policy will propagate all the metadata. Obviously, this is a crucial phase because you have to deal with failures. And from this point of view, ADX is not so smooth. Okay, so if something is wrong, is not 100% clear, clean, and so on, that is, you will have a failure. And the first thing to do is to monitor and control failures using, for example, a time-triggered periodically logic up. Okay, periodically time-triggered logic up, in order to be notified if there is some failure, for example. This is a sort of example, okay? But when you deal with the assets, you deal with broken files every day. So this important pattern, you have to use it when you have data ingestion phase and target table. The first table is never wide. In my experience, neither the second, but you can have, if you stay into the boundaries of the columns, you can have wide tables. But in my opinion, and from the product group, the best way to do things is to have fact dimension tables. After that, at the query stage, you can join the data. This is the most important thing to say. But if you need for some reason, and if you don't want to elaborate wide tables using external functions, and you do not have developers and so on, you can do that, but respecting the limits, okay? And probably spending some more dollar because of the compute needs about that. This was an example, going fastly. Imagine that you have logs. Logs are not structured, logs are not JSON compliant, so on. Okay, you can do your test, okay, using the Kusto Explorer or a web page with the dataexplorer.azure.com, as you want. Many tools in order to deal with the Kusto. And you copy and paste the data, your unstructured data into the query workspace, and using, for example, the parse method, and project away, so extract the data from the parsed result, you can have this kind of result. Very good. And when you have tested this, you can put all the query into the function used to do the update policy. And so if you have to create, so if you create the original source table, you can create preemptively or with the set command with the limit 0 the target table. After that, you can activate the update policy. So every time something send you logs unstructured, you can have a repository that is structured, full of facts. From the other side, you can have another ingestion pipeline with the user session and so on in order to join users, so people, processes, and so on, and logs, so errors or strange operations or recurrent operations and so on. Consideration. Transactional or not? Yeah, if you put transactional, you guarantee consistency. It is obviously, but if some is if some failure happens and you are not notified about that, and you define the soft delete to 0 seconds in the source table, you lose the data. So keep attention. Tag propagation, yes, you can. You have to propagate the every time the ingestion properties. You can propagate and add in another step. So if you are using ingestion properties, probably it is better to propagate it. Retain original data or not? It is a good question. It is a very good question. This is my idea, personally. Okay, if you have different flows with different requirements, consuming the data in both tables. So, if you want to have the possibility to explore the raw data because you have failures, because you don't find the data for every time, please retain the data. If you are sure that all the retained data, the data is cleaned by design, okay, because you have developed the edge phase, okay, so the data, if the data comes to the cloud, it comes cleanly in a clean manner. So in the other cases, if you are sure about the ingress, you can you shouldn't be retained at all. And in order to do that, it is very yeah, you have to alter merge your source table using the policy retention with the soft period of 0 seconds. Easily. 5 minutes. I prefer to choose this argument because in the IoT, this is the next step of IoT. Okay, so I want to select this argument instead of the other 90 slides that, if you want, I can share with you. Okay, ADT. So digital twins. Digital twins. Azure Digital Twin is a very good service, and probably it will be the future about IoT. But you know, the present is nothing if you do not consider the past. And so something was missing. So a link between the time series databases, so the past, and the digital twin, so the actual value of a digital twin. And it is not only the representation of a graph with many attributes, okay? Because the most important parameters are not directly generated from the field, but are emulations or remember, emulations or calculations, okay? And so you have to bring together the meaning of ADX and the meaning of ADT. So ADX and ADT has joined together with a partnership, okay? And so there is a plugin that can link together these two services. It is very, very simple, very, very extremely simple. So in your query environment, you have to put two variables. The first one is the endpoint, the ADT endpoint. And the second one is the query that you want to do in the digital twin service. So select some group of digital twins. And when you use the evaluate inside, okay, inside a more larger query, you can have the bridge between these two kind of service. And so you can, for example, have an update policy to enrich the data with the device twin ID. So use the update policy to bridge the two services using a query in order to retrieve the digital twins ID, enrich the raw data with the ID. After that, you can join the data from digital twin to ADX in order to update, for example, even Azure Digital Twin. This is only an example, okay? So this is the mapping, this is the update policies, this is the query. And for example, in this query, you have to, you can select, for example, a group of twins, and you can extend using the twin ID, okay, made during the update policy, with the Azure ADX data, okay. And in order to do what? In order to pivot the data, generating a new table, as you can see. So you can pivot the data, okay. And this is the final step. Render with extend, obviously, with some functionality in IDX that you can find in IDX, for example, anomalies, anomaly detection, and then render in an anomaly chart. This, I'm finishing. This is the dashboard, okay. All these examples, you can find them in GitHub. But for example, with this example, you can, this is only ADX UI. You can add external users to do only this kind of interface. And this is the result of the queries that I show you some minute before. And with this approach, you can bring, in order to summarize the session, bring the data from the field. Elaborate the data using the update policy. If you have the possibility to use, using IoT Hub, the Azure Digital Twin, use it in order to collect the state, the machine status, and so on. During the update policy, enrich the raw data with the twin ID, and then produce dashboards that brings data from ADT and from ADX. In this way, you will have a complete telemetry platform. Probably the time is gone, and I hope that you enjoyed this session. And if you want, we can go on with the other discussions.
We have a break, but you know, if anybody has any questions, real quick,
yeah,
I'm open to staying and facilitating that.
Yeah, absolutely. This afternoon for me, so your morning, I will stay on Discord in the IoT Data Chat. If you want to ask me some schema or architecture design or some particular tricky function in IDX, I'm at your disposal.
So any questions, guys?
Okay, it seems not.
Okay,
Everything
well,
is clear. So much. Everything is clear because it is simple. Okay. Thank you for your attention, and have a good Data Geeks Saturday. And that's all for Italy. Bye, guys.
Thank you, Riccardo. Thank you so much. This was amazing. I mean, I learned a lot. I don't know about everybody else, but this was great because my own use case is not around IoT at all. So very interesting to see how it's being used outside in the world.
Okay. Thank you, guys. Bye.
All right.